Okay, so here we go, talking about hypothesis test. So we're starting with this heading. We're going to do the four-step format, just like we did for a confidence interval. So I've drawn my lines here. I've labeled them information, conditions, calculations, and conclusion. Okay, the same four areas. Yeah, there's a lot of stuff in there, but we'll get to that in a moment. So here we go. So we got a 96 report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all American homes have at least one smoke detector. Interesting talking through class today. I had one class where all the people that I had in class, none of them had a smoke detector. That's kind of crazy. I thought everybody had smoke detectors. I've got four in my house, but I've got a little bit of a paranoid wife also. If you're married to me, you'd probably be paranoid also. A city's fire department has been running a public safety campaign. We're saying that city is Sherwood. How about? So they've been running a public safety campaign about smoke detectors, have posters up around in the various places, billboards, ads on radio and television, and in the newspaper. Of course, we can mark out newspaper now and put it on Facebook and on their Instagram account and stuff. So the powers that be wonder if this concerted effort has raised the local level above what's the national rate? 90%. So did it raise it above the 90%? So the building inspectors go out and visit 400 randomly selected homes. 400 randomly selected. That's pretty important to us, right? Matter of fact, that's our first condition, randomly selected. And find that 376, okay, this is our X, this would be our N, have smoke detectors. Is this strong evidence? All right, folks, is that strong evidence that the local rate is higher than the national rate? Okay, first, let's talk about strong evidence. When you see the when you see the phrase strong evidence, that means some type of test. The phrase strong evidence means some type of test. And in this case, it means a hypothesis test. A hypothesis test. So we're talking about percents. Percents are proportions. We have percentages, which leads us hopefully to think proportions. And with proportions comes hopefully the thought of a z-test. So strong evidence means we're going to run a z-test. Well, we only have one sample that we're talking about, so it's a one proportion z-test. And we're thinking that the local rate is higher than the national rate. And this is pretty important. This is going to be part of our answer. So here we go. Let's look here first at the information that we're given. From this paragraph, we learned that there were 376 homes that had smoke detectors out of 400 randomly selected homes. It told us the parameter, the 90% is a parameter because it's all American homes. So P is 0.9, Q is 0.1. These two added together have to equal 1. Well, again, we have 376 and 400. We do our division there. That equals 0.94. So my P hat, my statistic from my sample, is 0.94. Q hat is 0.06. These two added together have to equal 1. Which leads us to this thoughts here, okay? For this, we have what is called a null hypothesis. The null hypothesis is the idea that we're trying to disprove. And the idea is that the city is no different than the rest of the nation. Okay? Well, the alternative to that is that the public campaign, the safety campaign had a positive effect, and that again, it is higher than the rest of the country. So we deal with what is called the null hypothesis, H sub 0, and the alternative hypothesis, H sub A. That's an O, that's an A. Notice there's a colon there. We said that the null hypothesis is what the national parameter is. P equals 0.9. But for our place of living in Sherwood, The alternative hypothesis is that P is greater than 0.9. It is higher than. Okay, mathematical symbol for higher than is greater than. And then you see this funny looking thing here. This is called my alpha value. This is called alpha. It is the standard by which we measure everything by on our test. And we're saying that alpha is 0.05. That means 5% of the time, if you will. Anything less than 5% helps us to show this. Anything equal to or greater than means that we're not, that this may be true. We don't think it is, though. Before we can do that, we have to come and do our conditions. So here they are. It told us there were a random sample of 400 homes. We know that 400 is less than 10% of all Sherwood homes. Our success failure, NP and NQ, 400 times 0.9 is 360. That's greater than or equal to 10. NQ is 40. That's 400 times 0.1. This plus this have to equal that. This minus this equals that. Doesn't matter however you want to show it. That is also greater than or equal to 10. We have more than 10 successes and failures. The conditions are met to use the normal model, and we're going to create what is called a one proportion z-test. This is not an interval. Notice there's no z star over here. This is a z-test. It's a hypothesis test because we have a null hypothesis. Okay, so far so good? I hope so. So to do that, we then do this. We first have to find our standard deviation because we're going to need a z value, a z score. So sigma is the square root of PQ over N. This is on the formula page. So 0.9 times 0.1 divided by 400 is 0.015. Okay, easily found on the calculator. Then we find our z score, which is p hat minus p over sigma. I've told you to write this down a dozen times. P hat minus p over sigma. So 0.94 minus 0.9 divided by our new standard deviation, or the only standard deviation we have. And that gives us this z-score of 2.6666666. It's a repeating 6. So hopefully we know that's going to pretty much round to 2.7, or we can leave it as this, either one. And then that leads us to this. The probability, what is the probability that P is greater than 0.9? This is always our alternative hypothesis. Back up here, our alternative hypothesis, P is greater than 0.9. So that equals, that's the same thing as finding the probability that Z equals 2.7. I just rounded this. These are equivalent. That's the same thing there. So either of these two are acceptable. They'll expect this. You can write both. So what's the probability that that occurs? Well, to find that, it ends up being this number. We run what is called a z-test. Okay? We're going to run a z-test. Excuse me. So we go stat. We go over to test. And if you look, there's a z-test. And here's a one proportion z-test. Well, we're running a one proportion z-test, not just a z-test, because we have our proportions, we have our numbers. So I'm going to 5, and there's my numbers. There's my null hypothesis we said was 0.9, so that's our first number. There's x and n, which we easily identified. And then my alternative hypothesis says greater than. So if you'll notice here on the proportion, that's not equal to, that's less than, this is greater than. That's the one we want. And don't matter the color there. So we're going to calculate, and there's our numbers. Okay? The proportion that is our value is greater than 0.9 or 90%. There's our z-score, which we found the same thing. I'm going to skip that value right now. N was 400. Our p hat was 0.94. So if you don't remember how to do any of this, if you can go to stat and test and put these numbers in, then it finds all these numbers for you. And you'll see them hopefully say, oh yeah, I need that. Oh yeah, I need to write that. I need to write P and Q down. So this middle value right here is called the p-value. That 0.0038 ... That is called the p-value. That helps us determine By comparing it, we compare the p-value up here to our alpha. If this number is lower than alpha, then we're going to reject the null hypothesis. If this number is equal or greater than 0.05, then we're going to fail to reject. So we either reject or we fail to reject the null hypothesis. We either reject or we fail to reject. We never accept. Please, please, please never use the phrase accept the null hypothesis. Here we go. Here's our conclusion. With the p-value smaller than 0.05, that's alpha. You could use either phrase here. Remember, our p-value is 0.0038. Since it is smaller than our alpha value, we reject the null hypothesis, also known as H sub O. If you want to write H sub O or you just want to write we reject the null, that's acceptable. There is strong evidence, our phrase from the beginning, remember? Is this strong evidence that the local rate is higher than the national rate? And that is our answer. There is strong evidence the local rate is higher than the national rate. Okay, that's our conclusion. This is pretty much rote. You're doing this every time with the p-value smaller or larger. Doesn't matter. It's going to be one of those two phrases than 0.05. This number might change, but 95% of the time, no pun intended there, it's going to be 0.05. We reject, because it's smaller, we reject the null hypothesis, the H sub O. Now, I use the word strong here because I have two zeros over here. The more zeros between the decimal and this first number, the stronger the evidence. If this would have been, say, if this answer would have been this, if it had been 0.03, that's right below 0.05. That's not that great. I would have said there is evidence. Let's say that our p-value had been 0.07. Well, 0.07 is greater than 0.05, so then we would have failed to reject. Everything depends on alpha being 0.05 and the p-value the calculator finds for us. Okay, so that is running a one proportion z-test. I'll leave that there for you to look at, peruse, go over, rewatch the video. I hope you have a good rest of the day.